All right, let's jump right in. Now, on the surface, this looks like a pretty simple road trip, right? But what if I told you that planning this trip is actually a really fascinating math puzzle in disguise? Today, we're going to see how two totally different ways of thinking can lead us to the exact same answer. It's pretty cool. So here's the setup. Our guide, David, is driving from Marion all the way to Chicago. And along that route, there are 7 potential cities he can pop into. Mount Vernon, Salem, Effingham, you see them there. He can stop at every single one, just a couple, or, none at all. The one big rule, he's always moving forward, no driving backwards. The path is set.
And that, right there, is the big question. With 7 possible stops, each one an option, how many unique journeys can David actually make? I mean, just take a second to think about it. It feels like there could be a ton of combinations to keep track of, doesn't it?
Okay, let's try to solve this with our first perspective. I like to call this one the step-by-step journey. This is a very logical, path-based way to look at it. We're basically thinking about the trip as a series of connected routes.
Now, I know this is going to sound a little weird, but trust me on this. Sometimes the easiest way to count all the paths forward is to start at the finish line and work your way backward. So let's imagine David is already at that very last stop just before Chicago.
And this is where it gets really interesting. Look at how this works. If David is in Champaign, he's only got one choice left. Drive straight to Chicago. Simple. But if he's one city back, in Kankakee, he suddenly has 2 choices. He can either skip Champaign and go right to Chicago, or he can stop at Champaign first. 2 options. Now, from Tuscola, he can either skip Kankakee, or he can stop there. And if he stops in Kankakee, we already know there are 2 ways to go from there. So the total ways from Tuscola doubles to 4. You starting to see the pattern here?
And here it is, laid out plain and simple. This pattern is just so powerful. Every single time we take one step back from Chicago, the number of possible ways to finish the trip doubles. 1 becomes 2, 2 becomes 4, 4 becomes 8, and it just keeps going. So if you follow that doubling pattern 7 times, 1 for each of those 7 cities, you get 2 to the power of 7. And that means, starting all the way back in Marion, David has a grand total of 128 possible trips. So there we have it. By working backward, step by step, we've found our answer. Problem solved, right? Well, maybe not.
What if we've been looking at this whole thing the wrong way? What if counting all these different paths and routes is actually the long, complicated way to do it? Let's just completely reframe the problem. So now, let's switch gears to our second perspective. This one builds a totally different and I think much simpler picture. Instead of getting bogged down in paths, let's just think about simple choices.
Now, the key idea here is something from math called a subset. And don't worry, it's not as complicated as it sounds. All it means is the collection of cities David chooses to visit. Since he can't go backwards, the order of the cities is already set in stone. The only thing that makes one trip different from another is which cities are in his little collection of stops.
This slide just nails the difference between the 2 mindsets. The first way of thinking asks, how many different zigzagging paths can I possibly draw? It's all about connections and routes. But the second perspective, it simplifies everything beautifully. All it asks for each of the 7 cities is, do I stop here or do I skip it? That's it, a simple yes or no.
And look how incredibly simple the problem becomes now. For Mount Vernon, David has 2 choices, stop or skip. That's it. For Salem, he has 2 choices, stop or skip. For Effingham, same deal, 2 choices. It's just a series of 7 independent yes or no decisions.
And when you've got 7 decisions, and each of those decisions has 2 possible outcomes, all you have to do is multiply them together. 2 times 2 times 2, 7 times. Or, to put it more elegantly, 2 to the power of 7, which gets us 128. The exact same answer we got before, but we got there through a completely different, and you could argue a much faster way of thinking.
So here's the thing. The number 128 isn't actually the most important part of this. What's really crucial is the journey we took to get there and what it shows us about how problem solving actually works.
This is the absolute core takeaway. The problem itself never changed, but how we looked at it, that changed everything. One perspective gave us this step-by-step doubling calculation. The other reframed it as just a set of simple, binary choices. Both ways are totally correct, but one might feel way more intuitive to you. The key wasn't about finding a more complicated formula, it was about finding a simpler way to see it.
And this idea applies everywhere, way beyond a road trip in Illinois. So I'll just leave you with this to chew on. Is there a challenge you're facing right now, maybe at work or in your life, that feels like a tangled web of complicated paths? And could you maybe find a way to reframe it as just a series of simple, independent choices?